Hello viewers, thanks for watching our videos. If not yet subscribed, please subscribe. So in this session we're going to give some short introduction on sets. So this lesson is very important and we have to see this video till the end. Without wasting your time, we'll start our sets class. So let take some sets A, B, C and so on. Then next one. So sets will going to represent, let's take sets will going to represent like this with some elements in this. Open the braces and closing the braces. This one is what it can called is roster form. Roster form. So let's take fill A is 1, 2, 3, 4 up to there. This form is known as roster form. And what is the set builder form? So set builder form, how you'll write is, so how to write set builder form is, just for this case only I will write set builder form. The set all x, so for this all x such that means you can put 2, that is 1 colon, such that for all x, set x all x, set all x, x equal to n. So x is equals to n, comma n belongs to capital N. So the small n is belongs to capital N means this is natural numbers. Natural numbers. Again, up to how many numbers are there? The small n 1, 2, 3, 4. Small n is less than or equal to 4 and close that. So what you can say is the set all x is equal to n. Here we need to tell such that all x such that x is equals to n, where n belongs to capital N and n is less than or equal to 4. So in this session we'll start how to represent some sets. What are the things they'll take? So let's sets take A, B, C, 3 sets. Again, universal set we will going to represent. Universal set will going to represent with capital I. Universal set will going to represent with capital I. And for complement, what is meant by complement I'll tell later. Complement A will going to represent with A dash. So up you have to show. Then proper subset. So subset we have to represent with C like symbol, long C symbol. So subset means all the elements which are there in A, it will be there in B also. So A is subset to B. So all the elements which are there in A, it will be there in B also. Then empty set or null set. Empty set or null set will going to represent with pi. We're going to represent with pi. And union. So union of sets. Union of sets A and B. A union B. So union first letter is U. For that you are going to represent U type here. Then intersection. So intersection will going to represent with A intersection B. Upward U for this reverse case. then difference will going to represent difference A minus B. So what are these meanings and all we're going to explain now. So universal set means it is completely all sets will be belongs to universal set. So what you can say is here is all sets which are presented, all sets will be subset to universal set. So subset means the elements which are presented in set will be there in universal set. Complement, A complement means we have to take A complement means universal set minus A. So what is that minus here is we have to the elements which are there in I, it should not be contained in second set, that is after minus which set will be there, it should not be contained in this, which are presented in I, that should not be present in A. Subset means I already told. Null set means null set, so pi will be equal to empty set, there is nothing, this is empty set. A union B means we have to add all the elements, in A and B. A intersection B is, so common elements from both, sets A and B. So which are common in both, that one only you have to take. Then A minus B is what is that is actually the elements in set A not in set B. The elements which are presented in set A that should not be present in B. That is the meaning of minus, subtraction. Universal set will be, all sets will be subset to universal set. Subset means some elements which are completely, all the elements which are there in A, it will be completely there in B also. That is the meaning set. So some formulas, important formulas I will give now. So make note, make sure that try to practice. So A is subset to universal set. All the sets will be subset to universal set, and A is subset to A only. So always one set will be subset to itself. Next, A equal to B means, so if it is A is equals to B, then what you can say is, if A is equals to B, sets will be A is subset to B and B is subset to A. Then if it is like this, then A is, two sets will be equal. Next, empty set, that is pi is always subset to any set. So empty set, that is null set, always subset to any one set. Then what you can say is union of sets. So union of sets, what is that union? So let's take one set, that is A union B. So one set, that is A union B means I am going to represent this in set builder form for all x values such that x belongs to A or x belongs to B. Close that. Either element, x is a one element, either element it can be from, this is elements in C, element in C. So the element either it's come from set A, or it may be come from set B, like that, anything you can. Next, so for this what you can draw is, I just want to draw one Venn diagram for this. So Venn diagram, so draw set A and set B. So draw Venn diagram like this, set A and set B. A union B means it will going to show completely all the things. So it will going to show completely. So set A completely, and if we are joining, then set B also completely will take. So set B also completely will take. So if you add all the things, then what you will get is Venn diagram will get. So for Venn diagram for A union B. Then what is the next rule is commutativity. So A union B means A union B is equals to B union A. Then associativity rule is A union B union C. If you associated B union C with A union B associated with C. Next one, intersection of sets. Intersection. So what is that intersection formula is? Let's take set C, A intersection B. We will write it in set builder form X such that X belongs to A and X belongs to B. The elements which will take in set C, the elements which should be contained in A, and it should be belongs to B also, then only you can take it intersection part. The elements which are there present in both A and B. So for this I'll draw one Venn diagram. So for set A, next for set B, I'll draw one more set here, B. Just what you can say is draw elements here, all the elements set A completely, and draw set B completely. Set B completely. Then what is the intersection part? Which part we have to select? A intersection B means which part? So which place is combinedly it is there? Which place is combinedly it is there? Here it is joining. Where it is joining? It is joining here. So this portion is A intersection B. Where the two sets is joining, that portion is A intersection B part. That one. Next one, commutativity. You can take for intersection also. A intersection B will be equal to B intersection A. Next, associativity also you can take A intersection B intersection C. Associated both will be equal to A intersection B intersection C. That is possible with this. Next, distributivity property are A union B intersection C will be equal to, first of all we have to distribute both of this. First A union B, next intersection, next A union C. So what is the formula here is A union B intersection A union C. So like that you have to divide this formula. Next one, Next formula is A intersection B union C. So first of all, what we have to take is here is first A intersection B, next union will come again A intersection C. So what is that formula is A intersection B union A intersection C. So that are the formulas. Let's take now two sets, that is A union A, you will get A only. A intersection A, also you will get A only. So why? Because all the elements which are there in commonly it will be there in A also. Then this type of property is called idempotency. So idempotency. So if it is like this, we can call it as idempotency. Next one is A intersection pi. In pi nothing elements, in A some elements will be there, but intersection both are, you will get pi only. Why? Because there is no common elements in both. So that one again, A union intersection, A union with universal set, what you can call with universal all will be there, then these two are. So what you will get is here is these two properties, you can call it as domination. So domination is nothing but here pi is dominated A the set, here universal set is dominated set A. Why? Because every element will be there in universal set, so that is I, no element will be there. If you take intersection for both, then you will get domination here. Then what are the next one is, so let's take, A union pi will be equal to A, you will get A intersection I, you will get A only. So why? Because here we are getting that much values here is, so here A union B means if you add A set to the nothing means then you'll get A only. A intersection I means which are elements there in A, that same elements will be there in I also. Why? Because it is universal set, then you'll get A only. Finally, if you are getting A means it's not changing. If you do some operations with the null set and universal set, we'll get same thing. Then what you can say is identity. That identity is not losing here. Why? Because additive identity is 0, multiplication identity is 1. If you multiply with 1, no number will going to change. If you add 0 to any number, that number will not change for that identity. Next one. Next one, A complement, that is I minus A. So for this, what you can write is set builder form. X belongs to I. The elements, X means here element, X belongs to I such that X should not be belongs to A. That is the case here. Complement of intersection and union we are going to check now. So complement of intersection, A union A complement will be equal to what you will get, I. So how it came here is, so A union A complement means you will get universal set. Again A intersection A complement will be equal to pi. So with the A intersection I, nothing will get. Then how it came is A union I minus A. Then what you will get is here A union I will come. Why? Because the element should be presented in I, not with A. A union I will be I only. Then A intersection, this one A complement means I minus A, that will be equal to A intersection I will come, A and intersection with I, nothing elements will be there, means if it is pi. So next one, Our next one is De Morgan's laws. So what is De Morgan laws? De Morgan's laws. These are very important. These formulas are very important. So what is that is A union B whole complement will be equal to A complement intersection B complement. Then A intersection B whole complement will be equal to A complement union B complement. If it is the intersection will come here, if it is there intersection, here you will get union. If you will get union, here you will get intersection, opposite values. So next, difference of sets means, so let's take C will be equal to B minus A. For this set builder form, X elements such that X belongs to B and not X belongs to A. This is the set builder form. For this, if you draw Venn diagram means how it will be means, let's take B, again let's take A. So A, take the elements which are there in only the elements which are there in B only, not with A. It should not be contained with A. What is this? Is B minus A. This is set C. This is set C. B minus A Venn diagram will be like that. Then B minus A will be equal to B minus A intersection B. You can write like this also. So B minus A will be equal to B minus A intersection B. You can write. Again B minus A will be equal to B intersection A complement. Next A minus A will be equal to pi. A minus A will be equal to pi. Next A minus B will be equal to A if A intersection B will be equal to pi. A intersection B will be equal to A minus B is equals to A when A intersection B is equals to pi. There is no common element in both A and B. Then what is next one? Next one you can write like this. A minus B intersection C will be equal to A intersection C minus B intersection C. So here we are taking intersection and minus here in this. Then A complement will be equal to I minus A. Then Cartesian product. So what is meant by Cartesian product? So Cartesian product C will be equal to A into B. So sets we are multiplying. A into B will be equal to such set builder form X comma Y such that X belongs to A and Y belongs to B. Here X and Y are elements. X and Y are elements in sets. So we'll write it in the format of X comma Y like that. So all X and Y elements are therein. X should be presented in A, Y should be presented in X should be presented in A, Y should be presented in B, like that. Thanks for watching. Please subscribe.